Now, the advantage of having a fixed support here, where there is no real stress I am worried about, is that, it allows us to also consider some more sophisticated loading. So what I could add as well is an acceleration on the entire body, and that would take into account essentially the inertia of the conrod itself. So it's a situation where everything is fixed here, which is an approximation, but we don't care so much. But there is an acceleration on the rest of the body, simulating the inertia, and there is a force here, simulating the effect from the inertia of the piston itself through the pin. So by default, it's on all bodies. Nothing I can do about that. It's everywhere. And I'm going to do direction by vector. Apologies. Not by vector, by components, so that I can put it along the x direction. And accelerations on conrods can be quite large. So 5,000 G is not uncommon, but the unit is very weird. It's millimeter square. So 10,000 for the acceleration of gravity. Okay, well, 9.1 that can be bothered. So 550. So 5,000. So I want 5,000 G. So energy is 10,000. So that's 5,000. So 5,000 times 10,000. So it's a lot of zeros. 6 zeros. No, 5 times by 10,000. Yeah, 7 zeros. There we go. So again, that can be a bit of a pain to do it like that, but stupid units. Okay, cool. So let's solve and see the effect. So at the moment I have got, it should be done, isn't it? Yes, the acceleration is done. Let's solve and see what it tells us. Okay, so reaction, how do you see that? Oh, interesting, has changed a little bit. So it looks like that doesn't change very much. Maximum is still here, yeah, fine, but has reduced a little bit. So in fact, the acceleration is reducing. That's not so surprising because it's going the same direction as the pool. If you want here, could have some effect here, but not really. What we can do, if you wanted to know the effect of the acceleration only, is suppress the bearing load and solve again. So yes, it's a relatively modest effect, and in fact in a different place. So positive here, and we get a probe around there. We got minus 26, so that's, yeah, that adds to the 350, and we end up with 324, something like that. Okay, so still we have got a slightly more complex scenario for the loading, and that is what I wanted to discuss here. Now that's all very nice, and it helps. Oops, sorry for that. So yes. So what do we do now? What do we do now is, well, first of all, I'm going to put my bearing load back on. So because that's the main driver. So I unsuppress that, and I will resolve to be able to look at things in a proper way. So go back to our 324. So 324 megapascal maximum at here, which is quite a large stress. Probably too large to. Of course, I would need to compare that to the material properties of the steel we have got, and again, that probably would be drop forged, so would have increased strength due to work hardening, but still, be good to compare that later to material properties. Still, can I believe that? Well, it's definitely the 0.83, definitely not. Okay, 3 to 4, rounding it, and even 3 to 4. I mean, the accuracy I've got on that is absolutely not guaranteed at all. So what I might want to do is to improve, to do a convergence study, to try to be as good, to get the value of the stress as believable as I can, and also, of course, to make sure that I am not following a stress singularity. Now, from experience and habit, it's unlikely that this is a stress singularity, but better be safe than sorry. There is no really hard edges, or I'm not doing anything fancy with contacts, so it's very unlikely. But still, it's good practice to carry out a stressing mesh convergence. So how to do that? Well, different ways. I could increase the size everywhere, but I really don't care here to have so many elements. There is not a lot of points. Nothing is happening here. On the other hand, I want to put my elements here, so I need to be smart with the stress. So these probes are annoying me, so I'm going to remove them. So I need to put more elements there and perhaps less there. So what have I got to play with? The mesh at the moment is 27,000 nodes, and that's quite a lot. That's quite a lot already. I only need 32K in the student edition, so it's not a huge amount. So I need to be a bit smart. So there are different techniques to do that, and we have seen some of them. And typically, I would insert either a sizing at a node here, and do different things to improve it, or another option is to also apply a refinement, and then to either modify it by hand or to use a convergence on one of the values that we care about. So let's have a look. Let's say we wanted to do a convergence automatically, and because the maximum is here and we are looking at here anyway, so the automatic tools could work. So let's have a look at the stress, and let's insert a convergence on that stress. Okay, so that convergence, we have done it, I think, already in week 2, but you need to change the allowable change to something a bit lower, otherwise it will accept it too quickly. So let's say 4% here. And last time we did it manually, because it was quite interesting to study it like that, but it's also possible to actually automate it. And to automate it, you need to modify the solution detail. So in the solution detail, the maximum refinement loop by default is 1, which is what it was doing in the second week when we were looking at stress singularity, to do it one step at a time. But you can also increase that to maximum 10. And that would, in theory, automatically do up to 10 iterations until the difference in stresses is less than the 4%. So let's do that. Let's hope that it's going to solve it automatically for us. But unfortunately, it doesn't, because that automatic convergence is not always working. So we have messed it. So how do I check? How do I see the error message? Click on messages here, and you can check. Double click on it, and it will bring back the message. So not supported for the type of mesh method that we have done. So it kind of forces us to do it manually. Though, okay, to do it manually, I would want to insert a refinement or a sizing here, but I can't. There's nothing to bite. So even if there is no vertex to that thing. I suppose I could select a face, yeah, but it would put all on the face. suppose I could select that face as well, but it's all this one. So what does that tell me? It tells me that I need to go back to my CAD package, in that instance Design Modeler, and apply some face or add some bits of geometry, very likely some vertices here, so that I can then, once I'm back into mechanical, I can then select them to add my sizings or my refinements. So that's pretty much where I am stuck here now, and I need to do some geometry some geometry modification, imprinting faces, basically, like we did in the first tutorial, to be able to then be a bit smart on that. So while I'm at it, I probably will cut it here to have a vertex here, and I probably also will make sure that I can select only that bit of the face to do a job to refine my mesh, to put my elements where they will count. Okay, so I will now go back to Design Modeler.